Going to be doing JavaScript today. So what's bad here? What am I seeing here? It's like some browser cutoff. That must be PeerTube. Let's get rid of that. We're in good shape. Anyway, so what are we going to do today? We're going to go back to TypeScript. We're almost done. We're like doing, I think, type manipulation. It's like there's three sections left in the official documentation, so we'll do that. I am getting my voice across. Okay, great. I don't want to do like newbie mistakes that I seem to do so often. Oi, Blastoderm, how are you? We're going to be doing TypeScript. I've been so busy. I started a new job, so it's been like crazy trying to come up to speed. Most of the work is in JavaScript and TypeScript, so good thing I've been learning this, right? So, let's see. Let's see where we were with TypeScript here. Let's make this browser a little bit smaller. There we go. I think that's all right. I wish I had something to put up on top here. I guess we can just make chat longer or something. Anyway, let's try to remember what we were up to. We're doing type manipulation. There were generics here. I remember doing generics. Is oi Portuguese? I have no idea. In French, you say salut or you say bonjour. Generic types, we did all this. Pretty sure. Generic classes, I had a hard time remembering classes because like I didn't know JavaScript classes. So let's look at this. You have a class, generic number. It has a 0 value and it has an add function. And then we're calling new on it. Oh yeah, someone was arguing that this was kind of bad example. Okay, what else was there here? Hey Findus. Um, you're from Brazil. Oh, that's cool. I speak French. I am not French, but I speak French. I live in France. Using type parameters and generic constraints. What was this thing? All right, this was cool. Um, maybe we should review some of this stuff, huh? It's been a little while. Um, what are we doing here? You can declare a type parameter that is constrained by another type parameter. For example, here we'd like to get a property from an object given its name. We'd like to ensure that we're not accidentally grabbing a property that does not exist in objects, so we'll place a constraint between the two types. Oh, we want to make sure it exists. Why did you say oi? It's okay to say oi. There's nothing here that says you can't say oi. Height. Let's make it 450. Now it's a little longer. I've been to Denmark a few times. I kind of like it there. All right, so what is this trying to do here? I don't know. Let's just start typing. It's a lot easier. Just type TypeScript playground. We'll get rid of garbage here. So what do we have? We had like, did we make it an interface? I don't remember. It was like, was it like we were trying to make a basic num type, get property? Oh, we're making a generic function. So it's like get property. It's a generic function. And it takes in a type and a key. Well, actually, I kind of like writing these in non-generic first, right? So we have a map and we have a key, and I guess we'll return a value. So we take the map, and what does it get? I think we can also do this, right? Key. Could you turn up your voice? Is it low? Test, 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 test. Oh, it's like suppresses it. Here, let me try something else. All right, so this, wow, that's kind of weird. It's like it doesn't want to get louder. Is this any better? But then when I turn on noise filtering, noise suppression. All right, how's this? This should be all right, right? My voice is so low. What could be causing that? Audio. I don't think I've changed anything. The audio looks all the same. Hey, Esmet. Yeah, I don't know. It looks like it's the same on my side. I'm really sorry that it's coming out unclear on your side. All right, so now we have a variable called like address book. And it has things like names, mapping to, let's make it um, let's make it heights. So Bob is 140 centimeters and Jill is 150 and Anne is 130. Then we do get property, address book, comma, and we have to give it a name, right? A key. Indeed, when I started your stream, I thought you were on mute. Only after I've cranked up volume, things got normal. That's so weird. That was all you, right? If anyone else finds that it's like really quiet, let me know. Where am I? So we get the, I can yell. We can get the name now, the height, and then we log it, right? All right, so this should give us back, oh, it gives us errors, right, because we didn't type it yet. But we're going to get the height, and Bob's height should be 140. So there we go, 140, great. So now we're going to say, um, we take in a map type, right? And a key type, I guess. So the map is type T and the key is type K. Map key. I'm kind of lost. Let's see what they do. So type. Object is type. That's what we had. Key is key. The only thing they did was extends key. Oh, right. There's that special thing key of. Right. I forgot about key of. And I think I wrote that down, like how key of works. Type functions, type parameters, and generic constraints. Wow, I didn't really like write anything useful here. I just copied it. What I recall was Kiev is going to return. Kiev is going to return the keys of that type, right? Here, let's play with it. Key of and I guess we give it a type, right? Type person. Okay, so whoops. Key of, can't find key of. What the hell? Maybe I can only make a type out of it. There we go. Key of person keys. And then I do this is going to fail because it's not type key of person. But name is okay because it's one of the keys in person. All right, I get it now. Let's catch up. Key of is funny. Classes and interfaces in TypeScript are not the same type as their names. TypeScript requires the keyword type of in order to represent the constructor type. Okay, not sure I understand. When we do class orange, the class itself isn't type orange, but the object created out of it. Right. I think I get that. We need key of to mean the actual class instead of the instantiated object. Well, what I understand is like when you do key of a type, it's going to give you the keys of that type. So you see like I can do person keys here and it's going to give, I can make it name or I can make it age. And that's legal because it is literally the, I can have another type here, compatible person keys, right? And this is going to be name, union, age, union, height, right? So if I make a Y here that is compatible person type, I can make it name. This is legal. But I can't make it foo, right? Right. So the funny thing now is I can have a function that takes in, um, I can have a function that takes in a compatible person type. But I can actually I can actually call it foo with a person key, I think, right? Because these two things are equivalent, if that makes sense. These two types are equivalent. So even though I'm taking this thing and I made a person keys here, I can call foo x. And it's totally fine with this. So when I run it, it's just going to print out age. Age. Oh, type of. Okay, got it. Yeah, I get it. Anyway, Kiev is kind of funny. Maybe we should kind of clarify this here because I kind of wrote Kiev here, but I didn't really explain it. And I know I'm going to forget. So let's make a Kiev section. So here we go. These two types are the same. Here, we don't need this example. This is like later. Oops. Should be height. Um, Kiev just grabs the keys of the type and makes a new type that is the union of those strings. Because I think it's always going to be strings. These two following types are equivalent. Person, name, and name. All right, this is a good example. Let's put it in our TypeScript thing. I'll just put it at the end. What the heck is it? All right. I hope that'll help us in the future. Key of what the heck is it? Key of example. Key of just grabs the keys of the type and makes a new type that is the union of those strings. I think that works. Okay, so let's go back to the example we're trying to do here. trying to understand. So we make a key type that is key of all the t's. So that means that k is going to be whatever you pass in, it's going to have all the keys of this type in k, right? K is going to be the union type of all of those. So when you do this, when you make get property and you pass in, oh shit, where'd it go? Person. Oh crap, k extends. How do I do this? How do I call this? Oh, I guess we don't have to call it. The fuck, help me out here. This is the function, but then we don't actually call it. I guess I can't really, I guess I could do, like I could do this and it's fine, right? Because it's going to infer that this is type T and this is going to be type K. But what I want to know is how do I pass in, like, I guess I can do key of person, right? There we go, right? No? Yeah, we can't pass in address book. We got to pass in a person, name, age, height. So let's pass in a name, age, height. Okay, so now we have a person, and then we have to pass in a key. And obviously, this key doesn't work well here because it's not a key of person. But we can say we want name, and name is a key within these three. So that's how it works. This is kind of a weird syntax that I didn't expect. But if you want to explicitly set um, the generic types, you would write key of person here. But you could just get rid of it and it would work fine. I think it's nicer to read it this way because then you kind of know what's going in. I don't know. I think it's preference. So we don't need this address book. Yeah, inference. How's your days going? Everyone having a good day? Oh, hey Trina, I didn't see you. How are you? You know, it's like my morning too, even though it's 3 p.m., like 2:30 p.m. So I'm with you. It feels like morning. I just showered and this is like the first thing I'm doing today. I was stuck, like I got out of bed. My girlfriend went to work. I said bye, and then I just passed out on the couch and I could not wake up. I was just like, you ever have that feeling where you're like, you feel like you're a mummy, like you can't move at all? The inferred type is interesting because it says key of person, but I find key of person not super clear because I guess you should know what. I guess it should be pretty clear, right? But I didn't know what key of really meant, so I don't see the type that it represents itself. And you can't hover all the time, right? Like you could just have stuff where you gotta hover all the time. I don't know. I think it's preference. Using class types and generics, we did this, right? Yeah, this was a funny syntax. what I recall was like we said that classes are basically like objects. Objects, they just have the new function. Something like that, right? Let's see. So, goddamn, this syntax just drives me crazy. Create factories in TypeScript uses generics. It is necessary to refer to class types by their constructor functions. For example, create instance A extends animal. Yeah, all right. Classes are constructor functions. Their type if type of name is type of name. What do you mean type of name? My day is just getting started. I'm about to have a shower and run some errands. Good, good. Errands are good. Get those things out. You got to take care of your life. I do my errands last and often I get in trouble. That's a good way to think about it though. So, classes are just functions that create an object. Is that a good way to think of it? So this is this a class? Maybe I should look it up. Here, let's just let's just bite the bullet. JavaScript class. Classes are a template for creating objects. They incorporate data, or did I already write something down here about classes? Let's see. No, nothing. They encapsulate data with code to work on that data. The type of class orange is type of orange. The objects orange creates are just type orange. I see. So the class orange is the same as type of orange. Classes in JavaScript are built on prototypes, but also have some syntax and semantics that are unique to classes. What are prototypes? Okay, prototypes are this. Oh, all right. Hopefully we don't have to read all that. Classes are in fact special functions. That's what you're just saying. And just as you can define function expressions and function declarations, a class can be defined in two ways: a class expression or a class declaration. Oh, this is good. This is good to know. This is a class declaration because it's kind of like function, and the name of the function. So class, name of the function. Here we have like basically a variable or a symbol, and then we have a class expression here. So there's a function. I guess you can call it whatever you want. Is that right? Constructor height width this dot height equals okay. Like function expressions, class expressions may be anonymous or have a name that's different. Wait, like function expressions, class expressions may be anonymous, all right, or have a name that's different from the variable that it's assigned to. Right. So here we could have a class that's assigned to rectangle that's not called rectangle. I guess here. Here's the example where rectangle 2 is this thing, but then we call it rectangle. Class orange, we can access its prototype like orange prototype dot prototype is an object which normally contains the methods. Oh my God. Is this a programming language? What's going on here? However, unlike function declarations, class declarations have the same temporal dead zone restrictions as let or const and behave as if they are not hoisted. Class body. The body of a class is the part that is in the curly braces. This is where you define class members such as methods or constructor. The body of a class is executed in strict mode even without use strict directive. I don't know what that means. Uh, okay, just whatever. It runs like more strict. A class element can be characterized by three aspects: kind, getter, setter, method, or field; location, static or instance; visibility, public or private. Together, they add up to 16 possible combinations to divide the reference more logically and avoid overlapping content. The different elements are introduced in more detail in different pages. Method definition, public instance method getter, setter, public class fields, static, private properties, constructor. Okay, this is probably the most important one. Well, let's read this. Private properties have the restriction that all property names declared in the same class must be unique. All other public properties do not have this restriction. You can have multiple public properties with the same name, and the last one overrides the others. This is the same behavior as object initializers. Elise, how you doing today? Sorry I was unable to join your previous live. I was busy. Don't worry, Blocks Hub Roblox. Blastoderm, yes, I'm learning just a little bit of JavaScript. This is not too much information. Come on, this is easy. The constructor method is a special method for creating and initializing an object created with a class. There can be one special method with the name constructor in a class. A syntax error is thrown if the class contains more than one occurrence of a constructor method. A constructor can use the super keyword to call the constructor of the superclass. You can create instance properties inside the constructor. All right, so we have, it looks like I can just create properties randomly here, right? So what kind of object should we create today? A class book, and a book needs a constructor. It should have the title, and it should have, pages, and maybe it should have text. Let's make it really simple, right? Probably this needs to be function, I'm guessing, right? No? Does it have to be a function? Where were we? Class, no, there's no function keyword. It's just constructor. And then I can do, very easily, I can do this title equals title. This dot pages equal pages. This dot text equals text. Okay, it doesn't like that. Maybe I need to then make, well, we'll see. We'll see the example. So let's look at the example here. Class constructor. This is exactly what we did, right? But it looks like it wasn't happy with that. So the same problem they have, right? Because they don't declare these fields beforehand. I wonder why they give us incomplete examples. Class fields. Weird. I guess that solves the problem. That's kind of funny. Static initialization blocks, sure. Methods are defined on the prototype of each class instance. Get. I see. You don't have to say function get. You just like say stuff and then you can do it. So you can do like, get. Oh, you say get. Is this going to have a problem? Description is a calculated thing that has the title and the pages. This dot title and this dot pages. And then we have this. How do I make this? Book.constructor. New. New book. My title. 100 pages. It was a dark and stormy night. And now I can do my book dot description and I can log that. What? I can't do this? The expression is not callable because it is a get accessor. Did you mean to use it? Oh, when it's a get, I don't need that. All right, cool. Let's try. There we go. Book my title, pages 100. Perfect. Hey, we got classes now. We know classes. Right. That's why length actually kind of works, right? Because in arrays, that's why length doesn't need the function. I can do length like this. And now I can just do like, that's why that works. Got it. All right, that explains why. So we can do something like type has length, right? Print length. So now I should be able to call print length and pass in my book and it will work, right? So we clear this out. We run and it prints 100. but we can also print anything else that has a length like an array. I love it. Okay, finally I get that part now. Yep. All right, so where are we? Classes, field declaration. With field with class syntax, the constructor example can be written as. What's the difference here? It seems the same. Private properties. What the hell? Is it like, oh, you put the hash to refer to private properties? We got to make like a class section here. They're private. It's an error to, all right, so we should also say creating a class, new class name parameters. All right, what else do we need to know? So we can choose fake or true private members. Is a true private. TS also has private keywords declare fake private properties. Oh. Okay, inheritance extends. Okay, so it just looks the same as normal inheritance. There's a super keyword. Okay, that's fine. All right. We're done with classes. We get it. So where are we now? So this is what a class looks like. It has a new function. All right. So when we want to pass in a class, this is kind of like the way TypeScript does it, right? It has an object that contains a constructor, and this is the constructor, right? I think that's how I understand it. New bracket bracket. So that means I should be able to do here. And in here, we're being passed in. Wait, I forget this every time. Type. Oh, yeah, the type is the return type. So it is a class and it has like, oh, fuck. Is it this? Oh, it's an object that contains a constructor that takes in a new and returns. Okay, I'm almost there. Colon, not this thing. All right, I think that's right. And now we just have to do return new C. Ah, crap. Not there yet. Close. Oh, C's on the outside. C is an object that has a constructor function. There we go. This is going to be hard for you to remember. Let's just put it in here too. Okay. I feel like I'm going back to stuff that we already did. I think we can just move forward. Let's go and learn something new now. We were doing, what part did we get up to last time? Maybe it was type of? We did key of. Yeah, we did key of. So let's do type of. C is the parameter. The angle curly brace is the type of the parameter of C. Yeah. Somehow I get mixed up into thinking this is like magic syntax, but it's really, at least everything up to here is normal. I guess it's just here that's a little weird because it says new, but so could I make a new, I can't make a new book out of this, can I? So here, would I be passing, what do I pass in? You pass into class. So this would only work with a constructor that takes no parameters. Because my book takes in all these parameters, I can't use it. So, okay. Let's go back. Type of. I don't think we did this. JavaScript already has a type of operator that you can use in an expression context. Type of hello world is return string. TypeScript adds type of operator that you can use in a type context to refer to the type of a variable or property. Oh, so this is a string type. I'm not sure what's going on here. How is this different than this says it's a string type, and this one, oh, I see. It's used in the context of a type definition. That's why. If you use it in the type definition part, you can put type of, and it won't be the string, but it's going to be the actual type. All right, got it. Right, I can add those to the new function. But then no matter what, it's not a generic create function, right? But it could be like create book. Wait, type of is JavaScript too. Just said so. JavaScript already has type of. It isn't very useful for basic types, but combined with other type operators, you can use type of to conveniently express many patterns. For example, let's start by looking at the predefined type return type t. It takes a function type and produces its return type. Here is a predicate. So it's a function and it returns a Boolean. K, return type predicate. Oh, there's a predefined type called return type. If we try to use return type on a function name, we can see an instructive error. Oh my God, what am I looking at? Remember that values and types aren't the same thing. To refer to the type that the value f has, we use type of. Return type of. So when we pass in here, we're passing in the actual object or the function, but here we're returning the type. Yeah, it kind of makes sense that we want to return, like if we're using generics and we have a t, we want the t to be a type, right? We don't want it to be an object. I wonder how you write return type though. Um, infer. I know infer. All right, so here we can use type of within the type, and this will just work. All right, I guess I get that. TypeScript intentionally has limits the sorts of expressions you can use type of on. Specifically, it's only legal to use type of on identifiers, variable names, or their properties. This helps avoid the confusing trap of writing code you think is executing but isn't. Meant to use return type of message box. Type of message box. Yeah, okay, this is no longer a type. All right. I can't help but feel like we didn't, or at least I didn't fully grasp it, but I get it. I get that you can call type of on types. The name of a function isn't a type. Yeah, I would expect not. Indexed access types. We can use indexed access type to look up specific properties on another type. Person, here goes, we have person stuff, and we have age, person age. Ooh, we're using a key of person to make a new type. The indexing type is itself a type, so we can use unions, key of, or other types entirely. Here, let's just make that simple example first. So we have a type like person. We'll just do it very short, right? Just to make it easier to write. And then we can make a new type called like is alive equals to person alive. I think that's what they did. And it's Boolean because we indexed into here. Can we also just do person dot alive? No. Class name. The indexing type itself is a type, so we can use unions, key of, or other types entirely. Type by one, person, age. Oh, this is interesting. Like, they're basically saying you can give it a union here, right? And now it's a string or a Boolean. But wouldn't this be the same as like as doing this? Right? Yeah, it's the same thing. This is just shorter. Key of person, so these are going to be all the names. String number and Boolean. Why Boolean? What do they got here? Maybe when you use key of in and you pass in a type, you get the values. So here, key of person. Oh, they're passing in. Oh, they're passing it in here. That's what they're doing. That's why it returns the value. String or Boolean, because it's basically running key of inside of it, getting the keys, and then calling person again on it to dereference it. That is crazy. Alive, name, person, alive, or name. Oh, that's so cool. These are so cool. I'm gonna forget these. I'm so scared, but these are so cool. You'll even see an error if you try to index a property that doesn't exist. Right, okay, so it's actually checking. Yeah. Another example of indexing with an arbitrary type is using number to get the type of an array's element. What? We can combine this with type of to conveniently capture the element type of an array literal. So here we have an array, and the array is filled with objects, and here's a type of Mary number. So first we're going to, wait, what is this doing? This is going to return like what happens if you pass in a number into this array, which will be this. And it calls type of that, which is name and age. Aha, that's pretty cool. So, but I have a question. So what they have here is they made an array of objects. And the objects had stuff like Tobias. Okay, so then they said we can do type P is equal to, and then we do type of object array number. I think something like this, right? And this is string, it's name and age. But now what happens if I put something that doesn't match? Ah, it's gonna union all of it. Love it. Love it. And now it said it could be a number. All right, that makes sense. Crazy. 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 Totally insane. How fun. Okay, so where are we here? We're doing type age equals type of Mary number age. This will be just a number, that makes sense. Or age to person age. Right now we're deriving it from here, so it's just number. Makes sense. Those are pretty straightforward. You can only use types when indexing. When indexing, meaning you can't use a const to make a variable reference. Const key age, type age equals person key. Key cannot be used as an index type. Key refers to value, but it's being used as a type. So type alive is equal to P. Let's see here. We have several things here. Name, age. I don't have an alive. Can I do this or no? What is going on now? P type of number. Let's make this easy first. All right, because it's optional, we don't know that we can do age. But if they all have age, then we can do it. But if I added this, then we don't know that we can do this. So there's probably a constraint here that we can do, but I don't know how you constrain it. Oh, can I write code here? Probably not. Well, this is beyond my pay grade at this point. It's okay. Real realm and the type realm coexisting in harmony. Only the real realm. You can only use, all right, so that's what I was checking here. So let's say we have age, but it's saying that I cannot do const age and pass in a here, right? Because this is a value and not a type. Right, because this isn't a type. But this works. We can just say type. Oh, that's exactly what they do. All right. Well, we are good. We're done with indexed access types. There's no way I remembered all of that. Right, exactly. Well, if we use type of to get its type, we'll end up with just string though. This will just be string. And then we can't do that here. But I guess if we do this, Identifier expected. Yeah, I don't know how to do this. But I think it's okay. We know that we can do type. I think that's the important thing, and we can always figure this other stuff out later as to how to get an equivalent. Yeah, what if you didn't have the P though? I guess you need it. Type age equals P type of age type. Like here. Let's see. Where's age type though? You can have age equals age type of. Let's see. So we just have the string age. P type of age. This is number now. Right. But I was just trying to get the age, like the literal type age. Like type age. You know? How do I get this? It doesn't matter. We are good. We're done with this chapter. We're a little bit over an hour. I need to get back to work, I guess, so I'm gonna make it short. Yeah, type of age converts the variable to its corresponding type. Agreed, I get it. I get it now. We'll see if I remember it. So we'll do conditional types later. It's a longer chapter. Map types, little template literal types, then classes. Oh my god, classes is huge. This will be our mega session. Maybe we'll have to break it up. But we're getting there. We're getting there slowly. Thanks everyone for hanging out. I'm gonna get to back to work and actually look at TypeScript, I think. I will see you all soon. Thank you. Bye.